All right, Ben, welcome to 2024.
I don't know about you, but for me, time is slipping. It's an illusion.
I know. It feels like we were just in 2023 for a number of reasons. And yet 2024 feels oddly familiar.
It's almost like we were on a thread that was slept for a few weeks.
That's right. 176 is actually a pretty small release, and the release notes acknowledge this. So they say this release is relatively minor, but as always, even incremental improvements lead to a greater whole. I like that a lot.
Didn't this come out like the previous one came out like December 28th, and so this one was like during the holidays.
Yep, pretty much.
And so it's like, you know what, this like began being developed at like, you know, Christmas. Yep. And then like had like, you know, 2 weeks of just being holidays, and so it's like, you know what, maybe it's totally fun people to take their holidays and have a smaller release once in a while.
And I think, you know, this is one of the things you end up with when you have regular release trains, is that some releases are bigger than others, but that's fine. There's always another release later. And it's also fine to have some releases that are small. Mm-hmm. The first one, in fact, is entirely a documentation change, or almost entirely at least, which is the ABI compatibility updates. So there's now sort of in the function pointer documentation, there's a new section on ABI compatibility that just describes what it means for function signatures to be ABI compatible. Do you want to talk about what ABIs are, Ben?
Sure. So you've heard of APIs, right? Like, you know, if you're like, you know, I guess, you know, my experience is people who have done like, you know, coding boot camps is that APIs are like the big thing that you would do in programming. It's kind of like you have an API and you attach a thing to it, right? And you can think of maybe an ABI as like a very low level API where it's like, you know, imagine like, you know, assembly as to JavaScript is ABI as to an API, where an API is a very broad thing. It could be like, you know, a JSON endpoint on our server, or it could be like in Rust, like, you know, some method, some function on options, kind of very abstract, like we're calling this function, right? And the ABI is how it actually happens under the hood. That's how your platform knows, like your OS knows that when you call this function, what's actually happening, right? Like there is a stack somewhere, and there are arguments on that stack, and there's a return value, and then something happens. Right. I need to actually read what's compatible in here, what they are now specifying. But the idea here is that generally the ABI is how your system knows how to call a function. And there are some other things in there too. There's like, you know, it might know how, like, you know, data is laid out in memory in some cases, but mostly for the purposes of calling a function. Right. And so these differs from platform to platform, and like even for C and C++, they aren't like there's no actual de jure standards, only de facto standards that like some compilers have implemented. And if you are a compiler, you do need to know how to actually do this, or, you know, invent your own way of doing it. And I believe, you know, Clang and GCC agree on what to do for C and C++. But other than that, there's no like stable ABI. So if you're like compiling, you know, C on like your own random compiler for like a totally random platform, it's not like a stable thing. And having a stable ABI is kind of it's difficult. And so the Swift language has a stable ABI, which they can do because they went to monumental effort and years of breaking changes and like language design contortions to like make a thing that works pretty well if you're on an Apple platform. But what it gives them, what's cool about being API compatible, like, you know, de jure Swift has and de facto C has, is that if you have a library over here compiled with one version of some random compiler, and a library over here with a different version of some other random compiler, you can link them together, and it all just works out, right? There's no like, you know, mismatch between like, you know, what this, you know, function, this binary expects from this way of calling into this thing. And so Rust does not have that, notably. The default API, the ABI for a Rust function that you export from a library, it can change between compiler versions. And like if there was like more than one Rust compiler in use, it could change between, you know, compilers too. Right? And so the idea here is that normally in Rust, if you want to do this thing where you have like, you know, one version of Rust C has compiled this, one version of Rust C has compiled this, and link them together, you need to use the C API, that is, and say, hey, like, you know, we're going to export, you know, we're going to pretend that we're C, and because C is de facto stable and everyone agrees on this one platform, this one compiler, what a C thing should look like at the binary level, then we can just, you know, it doesn't matter that you have two versions of Rust C, they're both, you know, they're using the stable C API. And so I'm not sure, is this case, and again, I haven't actually even read what this is yet. Is this about the Rust ABI?
Yeah, so this is specifically documenting the Rust ABI for the purposes of, I think, function pointers in Rust to Rust calls.
Right. And so, again, Rust doesn't have a wholly stable ABI, but there are some parts of Rust that are stable. And so, for example, if you have an option that contains a reference, that is always going to be guaranteed by the compiler that will always be just a pointer at runtime. And so you can rely on this for things like, if you wanted to optimize your code like that. And so there are a handful of things that are guaranteed. And so again, it's not the entire ABI, because stabilizing an entire ABI is a monumental task that also constrains you a lot in the future with like what you can actually provide. And so like one of the reasons that Rust does not say guarantee the layout of struct fields, unlike C, for example, is because, sometimes we can like achieve speedups if we actually like, go through and like rearrange your structs for you, which is actually really important for generic code, in fact. And so staying unstable in some cases is like good for performance, also good for flexibility in the future of we realize a new way of doing this that would be a breaking change if we had a stable ABI, which you can see in C++ is actually a big problem, right? We're trying to evolve the language while remaining ABI stable is one of the biggest problems in C++. It's actually like one of the things that holds them back the most. And there's a lot of people who are kind of like just break it, who cares? Folks who are like no, don't do that. And so one of the biggest riffs, I think, in terms of like modern day of driving folks to have like post C++ things like Carbon or C front or I guess CPP front, I'm not sure what it's called. I've heard such a thing. But is like the debate over like should we have a stable ABI, and Rust does not have that. But I mean, people still kind of like, hey, like if we could guarantee that like a char is always a U32, that's kind of nice to have, right? Is there any risk with that? It's kind of like not really. Which I think is what's happening here, right? They're saying, hey, like, in this case, we can it's not a problem. Just say, hey, in the future going forward, we'll always guarantee that a char and a U32 have the same ABI, so you can use them interchangeably.
Yeah, and I think it's right? Also, I think it's important too to stress that an ABI does not guarantee semantic compatibility, right? It's not saying that if there's some function that's defined in some other thing that is built by Rust C that you link against, and then you define a header or the function definition for that remotely defined function, then if you declare one argument as a star mute t and they declare it as a ref mute t, then those are ABI compatible. Like the two signatures are ABI compatible, but you still can't call it with something that violates the guarantees on the other end. If you do, you end up with undefined behavior, but it's not ABI incompatible. It is just the semantics of the thing you're calling are wrong, or like you're calling them and not meeting all of its semantic requirements. ABI is purely on the sort of mechanical level of how is this function actually called or executed. And I think in this particular Rust release, basically all that they did was document the guarantees that they do and do not give. Things like, star const t and star mute t are ABI compatible. Or, an I32 is ABI compatible with a non-zero I32. And similarly, things that are not guaranteed, like I32 and F32 are not compatible with each other. Even though there's the same number of bytes, they're not ABI compatible. I think the only thing that they changed is what Ben was alluding to as well, is that char and U32 are now guaranteed to be ABI compatible.
You say char?
Char? Char?
I say char.
Char? It's too hard.
Mm-hmm.
Character. Is that not how you pronounce it? Character?
Character?
A character, yeah. I think that's how it's definitely pronounced. The next thing in Rust 176 is type names from references. So in the standard library, there's long been this function in the std_any module called type name. It's a generic function that takes no arguments. You call the function with a generic type parameter, and it will return to you a string representation of that type. So the idea is that this is handy for like debug purposes. If you just want to print out what a given type is, you can't really guarantee on this being like unique for different types necessarily. It is just a debugging tool, I think, since Rust 138. But the problem with type name that's generic over T and takes no arguments is that you can't always name the type that you want to print. Sometimes, like if you're in like a macro or in some kind of generic code, you don't have a handle to that type. You can't put it in there in the generic type parameters. And so in Rust 176, they added a function called type name of val, which takes a reference to any T, and then it prints out the type name of that T. So if you have an instance of a type, you can now also print the name of that type. So this is sort of an extension to the debugging tool for the cases where you can't name that generic type in the first place. Think of things like a closure, for instance, that you couldn't name and pass to the type name function that just takes a generic type parameter. Iterators being another example that commonly come up, like especially iterators that either use impl trait, like impl iterator, or that have like closures inside of them, so you can't really name them. And when I said that this was a short release, I wasn't kidding. Like those are the two mainline things in 176 that sort of made it into the release notes. And then we have a couple of stabilized APIs that we can talk about, but that's sort of the end of the major things they wanted to get across. Do any of the stabilized APIs stick out to you particularly here, Ben?
I was going to say, like, if you don't know what the inspect function is, it's a cool little kind of like, debugging sort of thing where like normally you wouldn't like use this for like, normal code. But what's stabilized in this release is result inspect and option inspect. And so normally the inspect is the thing that you would do if you had like an iterator and you had like a chain of things, you're like mapping, folding, doing a bunch of things. And you just want to know like, hey, somewhere in this chain, what's actually the value of every given thing? And so you can do an inspect, right? And then it'll just give you a thing. It'll be like, pass a closure to inspect, and then it'll give you the value of whatever it is currently at that point in the pipeline. And then you can have it, do like a print line or a debug, DBG, right? And just like have it, see what it is. And that's kind of all you want to do with it, right? And just a way of debugging your pipelines or your iterator chains, saying, hey, like, right now, what is the value of this? And so it's a little thing you should know about. And they, result and option are iterators, technically. And so you can inspect those too.
And I think the other thing that's neat about this, right, is that the alternative is really painful. So if you have you're doing a bunch of map and folds and stuff, or even if it's not iterators, you're doing a bunch of map and thens and map errors. If you actually wanted to print out what it is partway through something, then the way you would have to do it before is like break up your chain of function calls and like do like if let sum equals and then print the thing, or just print the whole thing and then continue your chain. Whereas with inspect, you can just sort of inject the dot inspect along the sort of chained function calls, and the inspect just gets a reference to the current value, does not return anything, and does not change the thing that's inside the result or the option. It's just like as Ben says, sort of inject the debug point into your code. That's really handy.
Right, and it'll also it only runs the closure that you pass it for inspect if in the result case if it's an okay, and in the option case if it's a sum, right? And so it's already unwrapped for you. You're not going to get like debug of a sum 42 or a none. It's going to be like 42 or no error in there too. So yeah, there is an inspect error if you wanted that.
Yeah, so someone pointed out in chat too that one of the things you could do, right, and before we got inspect, is you could dot map DBG of the input value. So DBG takes a value and debug prints it and then returns it. So it is semantically the same. The nice thing with inspect is that you don't have to also deal with returning it. So if you wanted to do something else, you wanted to like print line it, but in hex or something, that you could do that pretty easily. Whereas with the map case, you have to have something that actually returns the value to continue the chain.
Right, and so the closure that you pass to inspect, it has no return value, and it gives you a thing by immutable reference, and so it's kind of hard to mutate. And so you're not going to be using this for any kind of actual work. It's just for side effects.
Another thing that got stabilized is the unwrap or clone function for arc and RC. And this one is, also just mostly a convenience thing. Like there's nothing you couldn't do here with stable code before. But the idea is that if you have an arc and you want to get an owned version of the things that's inside the arc. So let's say you had an arc of a bool is a bad example because it's copy, but you have an arc of a file. Then imagine you wanted a clone of the underlying file. File is bad too because you can't clone a file.
A string.
All right, yeah, you're right. Arc is string. Fine. Okay, you have an arc of a string, and you want to get an owned version of the underlying string. So you could just call .clone, and then you would get a reference to the string behind the arc. You would be cloning it, so you allocate a new string, you copy over all the bytes, and now you have an owned string. But there's an optimization you can do here, which is if you are the only one holding the arc, like there are no other references to this arc, then you can just sort of steal the string from inside this arc and drop that arc, and then in the case where you are the only owner, you don't need to do an allocation, you don't need to do a copy. And so unwrap or clone implements this behavior. So the idea being that if you own the arc and no one else has references to it, then you get the inner value. Otherwise, it clones the value that's inside and gives you back the clone.
It's kind of like, if you know what copy on write is, this is kind of like copy on read.
Yeah, exactly right. Do you know anything about this default hasher and random state being moved into std hash?
I think it's just exported. I'm not sure it's been moved. I think it's just that they have now export them from, in certain library, there is both a standard hash thing and a standard collections hash map, right? And so I believe it's probably just now exposing these things that are conceptually hashes from the standard hash module.
Yeah, and I guess the motivation originally was that the default hasher and random state were really just almost implementation details of hash map. They weren't really something that you should use for other things. They were just used for hash maps, but they needed to be public because they were part of the public type signatures of hash maps. And I guess the reason they moved into std hash or were re-exported into std hash were presumably because they recognized that actually the default hasher might be useful for other things as well.
Well, I think no, these aren't newly exposed, and so default hasher and these things are from 1.7. And so it's just that this is just announcing that they now are available in new places. They have been moved, and their old, I believe, locations have become type defs to the new locations.
I guess what I'm getting at is I'm wondering why they were moved. Like presumably that's an acknowledgement that these types are useful beyond just hash map collections.
Okay. I mean, yeah, I don't know. Like if you have a hash and you want to get the state, I think it's fine to say, hey, it's independent of hash maps because hashes are useful for things. So
yeah, the only thing that's tricky, right, is
the
default hasher is like non-defined. Like it doesn't define which hasher it's using, so you can't really rely on it producing any particular hash, which is usually what you use hashing for, right?
Mm-hmm. But it's the hasher used by a random state, which is again,
that's true.
A thing that is specific to a thing. And I mean, there is that hilarious hack where if you're like, oh, I don't want to pull in a dependency for RNG, I just want to have a random value. Well, random state for hashes is random and per thread. So
that's terrible, Ben. You should not be telling people this. They will start using it.
For a long time, Tokyo did this because they didn't want to have a dependency on rand. So I don't know if they still do it, but they did for a long time.
That's funny.
I mean, I want randomness. I don't need the rand crate entirely, but what I want is all of the underlying entropy sources to be available from std. I think it should be in standard IO.
Yeah, I mean, you're not wrong. Notes. You're not wrong. There's another thing that's added here, which is pointer adder equals, that I thought was an interesting addition. No, it's a function. So it's a function that takes two star consts and it checks whether they point to the same address. So it does not check whether their values are the same, but whether they point to the same address for the data section of them. And looking at the docs here, it specifically is, I think, relevant for fat pointers. So if you have a fat pointer, this will only compare the data section and not the other part, like the length for slices or the vtable for trait objects.
Interesting. So if you had a vector and you took two different slices to it, and one slice was longer than the other, they would not compare equals, but they would compare adder equals, right?
Yes.
Is that how it goes?
Yep.
Okay.
And similarly, if you had two DIN references for different traits, but they were actually the same underlying object, then they would adder equal the same. Like I construct a foo, and foo implements the two traits bar and baz. And so I create a ref din bar from foo and a ref din baz from the same foo. Then those two ref dins would adder eq because they're pointing at the same foo, even though they have different vtables. And I think this is probably in preparation for the stabilization of things like pointer metadata, which we don't really have yet, but it's sort of getting there, of the ability to specifically get at the two parts of a fat pointer, like the sort of metadata associated with the vtable, for example, and breaking that apart from the data pointer. Someone in chat is asking, would the expectation be that in something like Cherry, this would compare the address portion of two capabilities? I think so. I don't know whether this is going to also be architecture dependent or whether it's just talking about specifically Rust fat pointers. I'm guessing probably only the data portion of Rust fat pointers and not extent architecture.
Right. I feel like because Cherry, it's a matter of semantics, right? Like, do we consider Cherry pointers fat pointers or thin pointers? I kind of assuming that they'd be thin pointers. I think we mostly care, in the Rust case, are these what Rust considers fat pointers and not like what the OS considers like metadata in a pointer? Yeah, I don't know. It's a good question.
Yeah, it is curious. Like, I do wonder, like, when we see the implementation of add or eq, is it going to be architecture dependent?
Well, yeah, let's look at the implement right now, right? So it's a single line, add or eq, where it's just, we cast each pointer to star const nil, and then we compare them, right? And so it's kind of just like throwing away, imagining that this was a pointer to nil, what is the address?
Yeah.
Right? Which, seems like in Cherry it's treated like a thin pointer, not like a fat pointer.
Yeah, I think that's probably
so I'm
right.
not sure from user space you could really modify, even like kernel space shouldn't be able to mess with metadata in a Cherry pointer.
Yeah, I think you're right. I think you're right. It would be weird, right, if Rust started masking out bits of the pointer before comparing them, depending on your architecture.
Yeah, I guess it's arguable what they want or what people
Right.
need this for. So
apart from that, I don't think there's anything that stuck out to me, although I think we've talked about basically all of the stabilized APIs at this point, so I guess they were all interesting. In the changelog, there was only really one thing that stuck out to me, which was another rustdoc improvement. They're really just... rustdoc is on fire these days, which is that they now allow resizing the sidebar and hiding the top bar in rustdoc, which was not previously the case. But now you can drag and pull on the sidebar and get rid of the top bar to really, really focus in on the reading. Did you find anything in the Reddit thread this time that people are particularly excited about?
No, people just like happy about inspect.
Nice.
So
yep.
functional programmers were rejoicing.
Yeah, that checks out. In that case, I think we can jump straight to 177. This one was a piece of cake.
Yeah. Easy. We'll
So
leave
we're-
the intermission.
Yeah, we need the intermission tune again. What intermission tune do you want to use this time?
At this point, we can align it. It's like a no-op this time. And so Rust C has
Oh.
optimized out the intermission.
No, I have a perfect intermission, which is dun 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 dun, which is the Pokemon Center healing sound when you bring in your Pokemon.
Okay.
Yep.
I can
Which
hear
feels like a good intermission, right? So we're forwarding our brains now, Ben. We have to do something we've never done before, which is time travel from February until March of 2024. And in 177, the first thing that we got is C string literals. What are C strings, Ben?
Right. So C strings were a mistake. Anyway, there's back in the 70s, right? There were two different ways of thinking about, okay, well, we have like, a string. It's a bunch of data. It's a buffer full of data, right? How long is this buffer? Who should be responsible for determining how long this is when you want to like read it, right? And there's the Pascal way of doing it, and there's the C way of doing it. The C way of doing it is you have, your bytes in a row. And when you get to a null, that's the end. How do you store a null in your string? Just don't do that, right? And the Pascal way of doing it is you have metadata, which kind of like Rust slices. It's literally the exact same thing Rust slices, where you have, your string is a fat pointer. It has the capacity up front, and then you have the data, right? And again, it's, in 70s, and so your capacity might be limited to like, I don't know, a single byte, possibly. And so not, ideal. C string could be longer in theory. But I think, nowadays people have realized, it's actually kind of a big problem to have these null terminated strings where if you look at like, I want to concatenate two C strings. Be careful how you do that. I want to I want to slice it. Be careful how you do that, especially if we're kind of like, okay, great, I have a C string. Let's just take a substring of that. And now let's run off the end of memory because there's no null anywhere in that because we sliced off the end, which had the null on it. And it's kind of just like, you know what, maybe we should just care about the length of have things hold their data about how long they are if we need to have that, right? But if you want to interop with C, you need C strings. And so there are types for these. There's both C stir and C string, which are the same things as, as stir and string in Rust, where one is, a view and one is the actual allocation behind it and backing it. But they have null terminators on them, right? And so you can safely pass them to and from C. And this is just a way of making them have support for string literals, right? And so in the past, I assume you would have had to do like like how you might see string, capital S string : from a literal. And I assume in the past you had to do a C string : from, and then like, maybe have it as ref to get a C stir out of it. In this case, now you can just put, the letter lowercase c, quote, your string data, end quote quote. And this is using the feature of Rust 2021, which allows you to have arbitrary prefixes, allows the compiler to reserve the syntax to put prefixes on front of string literals. And that was my RFC. So you're welcome.
Thank you, Ben. So when are we getting F strings?
F strings? That's beyond me. I wrote the RFC for F strings, and someday. So
I think the argument for C string literals rather is specifically that it allows you to not have to do an allocation. Right, so if you have a standard Rust literal and you try to turn it into a C star with like C string from,
it's too short. You need one more byte.
Yeah, exactly. You need one more byte. And so therefore you can no longer use the thing that you had in memory. You need to allocate a thing, and then you need to copy all the bytes over and then add a null at the end.
And I believe that some languages, like it might be Go might do this. I'm not sure if it's Go or not, so I could be lying here. But some languages that are Pascal-like, where they keep the buffer length around you, always allocate a null at the end just to be safe in case you cast it to a C string and there's going to be a null somewhere. That's one thing Rust could have done.
I am curious how this interacts with... so we have byte strings, right? So we have the B prefix. Do you know how B and C interact here?
I would conservatively say start with just an MVP and don't let them interact. But I mean, try it. Pull up your playgrounds.
I'm guessing that they don't, right? Because a C string already returns a C star, and a B string just makes it return a U8.
Returns, the U8 slice.
So if I do here...
Maybe it returns a null terminated U8 slice, which I mean is a thing that you might want from C. So
let's see. What if
I wouldn't even say, I would do like, let :nil equals BC and see what it spits out at you.
Well, I was going to do this.
Okay.
So if I print line :x question marks to get the hex
we
for
can use
B
that
foo.
name of val thing that was stabilized.
Oh, yeah, you're right. I guess I can do that instead. So stood any type of val, bfoo. It's type name of val. Type name of val. That's a U83. Okay, so a B foo gives you a U83. That's fine. A C foo gives you a core FFI C string C star. A BC foo does not compile. Prefix BC is unknown.
Can we do raw? Can we do RC foo?
Oh, RC foo. RC is also unknown. What about CR? CR works.
Oh, there we go. So it's C. Is it CR?
Okay, so
there you
go. R meaning that you don't get any escaping in there, and double quotes don't have to be escaped.
I assume BR is the same way, where you can't do RB, you must do BR.
Yeah, probably. BR works. RB does not. That makes sense, right? Because I think the R needs to be next to the delimiter that you want to use.
The hash maps, the octothorpes, sorry.
Yeah, interesting. Okay. The next thing that we got in 177 is support for recursion in asynchronous functions. And here, I think this is one of those things that has been an open issue for a while. So this didn't really have anything to do with the sort of async if and in traits or anything. This is purely about asynchronous functions recursing. Do you know why this didn't work or why this was difficult?
So async functions compile to state machines, right? So I see no reason why a state machine couldn't loop over itself. It says they could not call themselves. It's possible that it was a name resolution.
Well, they certainly need to be sized, right? So if you have an async fn foo that calls itself, then how much space do you allocate in the state machine for the future that foo returns when you call it recursively?
So the state machine is calling.
Yeah, so you do need some kind of indirection here, which this also points to. Like you need to like box pin your call to self.
I see. It requires indirection.
So it requires indirection. I guess what I'm wondering is why it was hard before. Like if you did do the indirection, why was that not sufficient? And it might be because it like didn't recognize that the box pin, for example, was sufficient to make it sized. I'm not sure. We have Nils in chat. This is helpful. I'll prefix this with the same prefix he used, which is, if I recall correctly. So Nils says, the problem was that the coroutine witness type used for auto traits, etc., contained the stuff in itself, causing it to be recursive, causing an infinite type that doesn't work. Oh, I see. So it's not about what you put in the state machine. It is the type that expresses the type of the state machine. That type ended up having a recursive type in its name. And so it got confused. So even though the state machine would actually be sized, the type signature, if you will, or the type of the state machine would infinitely recurse. And I guess that has now been fixed. And presumably the fix is to add a similar kind of indirection to the state machine type as well, or the witness type as it's called. Nice. Yeah, I mean, this seems like an obvious win, right? And you previously could not have recursive async functions, and now you can have asynchronous functions that recurse. That seems pretty great.
Great. And then Neil Stream, while you're here, if you want to roll up our PR so we can get it merged before the stream ends.
Aha, it has been. R plus rollup.
Oh, great. The saga continues.
This is great. Meow once or twice for them. Meow. Meow.
Sophie,
we even have a real cat. See, the problem is if I meow, then Sophie might come and attack Ben's
you're
headphones.
not missing, don't worry.
Oh, damn it. Excellent. Okay, our PR is on its way to be rolled up and merged. This is pretty exciting.
Let's check the Homu queue.
All right, let's go look. All right, Homu, what do we got? Yeah, it's here. It's down here. We have there are a bunch of roll up always.
Oh, okay.
So there might be hope, but we're behind these guys though. Well, we'll see. We'll see. The race is on.
They have low priority, so
that seems reasonable. Okay, next thing in 177
here's a good one.
Yeah, this one's good. Offset of. This is a macro. What is this, Ben, and also why is it needed?
Right. So it's one of those things that, like, if you're a C programmer, you think about all the time. In Rust, generally not so much. Okay, let's imagine you have a struct.
Okay,
right?
I'm imagining it.
You're imagining in your mind palace you've got a struct.
I have a struct.
Okay, and it has two fields. You have a U8, and they're both U8s. Say, right, X and Y, they're both U8s. You have a point struct. Classic, right? Okay, and so you take the address of that struct. Because of the way that things are lit up memory, the address of the struct is also the address of the first element in that struct. Okay. And what's the address of the second element in the struct? Well, I mean, you could just get the field and take the address, but if you want to know for more arcane reasons, like you're doing something, some other lower level stuff, right? The offset of macro is a way of getting the offset of any field in a struct if you already know the pointer to the struct. Or I guess it probably even requires it. Is it the type name or is it a value?
The type name.
Type? Okay, yeah, so it's, and the idea is, talked about this before, is that in Rust, the ABI discussion, Rust ABI isn't stable. It's allowed to change over time, and in fact, if you have a generic type, then every instantiation of that type might have a different field order, because that's allowed. I'm not sure if it actually does that, but it is allowed. Right? And so offset of is a way of saying, hey, for this type, what actually is, the number of bytes from the start of the address where I can find this field if you wanted to go in there and do any kind of unsafe code, which requires it sometimes. And generally, I think before you could make it a repr-C struct and then just kind of count the bits and then know, which is how you do it in C. All right. I guess in C they have actually there is offset of in C. I don't write that much C. I don't do that kind of offset of level stuff, but it exists certainly. I'm not sure if it's in C or C++ that it exists.
So then the obvious follow-up question, Ben, is why is this not take a reference to the field, take a reference to the start of the struct, and just subtract the two?
For the same reason that it exists in C, right?
Yeah, and I think the leading part of the question here is because of packed fields or packed structs. So references in Rust have to be aligned. They are not allowed to be unaligned accesses.
Oh, there you go.
If you have a struct that has the little repr packed on it, then Rust is forced to put all the fields next to each other with no padding in between. This could mean that if you have a U64 field, then it's supposed to be aligned as a U64. So it's supposed to be aligned on an 8-byte boundary. So an 8-byte aligned address. But in a packed struct, it might be at a 4-byte alignment or something. Rust does not allow references to such fields. And in fact, it used to be that Rust would allow you taking those references. That's now disallowed because it's just wrong. It violates a validity invariant of Rust references. This gets complicated because people don't generally know that this is the case. So if you were to implement offset of yourself and you tried to take a reference of the field and then subtract, turn it into a pointer and subtract the pointer to the start of the struct, then you've actually gone into undefined behavior because you took a reference to a packed field. And so the offset_off macro understands how to compute this without taking any references. So you just give the name of the struct and the name of the field, and it gives you what the offset is. And I think there's a variant of it that takes a pointer to a struct instead and a field and does the same thing. But again, with the particular sneaky trick that allows it to never take a reference to a packed field and so still give you the value in a safe way.
I don't know about that. There is a pointer offset method. Is that what you mean? I don't see an offset of variant that takes a reference. So maybe it's nightly only. I don't know.
I'm thinking of, is it adder of?
There's adder of as a thing, but again, another reason that exists is because it's not always safe to take a reference and cast it to an unsafe pointer.
Right. So that was my point, that you can you use adder of, and you give it if you have a foo, let's say a variable foo that is a pointer to a packed struct, and you want to get the address of the field X of that packed struct, you have to call the adder of macro, adder of foo.x. You cannot do reference adder.x as *const. That would be undefined behavior because you're taking a reference to an unaligned field. And so that's why you need the adder of macro. And then moving on from dark incantations of alignment of pointers, the next thing we have is a cargo change, which is to enable strip in release profiles by default. There's a lot to unpack here, but the basic setting here is that cargo allows you to set a bunch of options in cargo toml for basically how to compile your crate. Things like how much debug info to include, what debug info to remove, what level of optimizations to use, etc. One thing that's pretty common to set is to set debug equals 0 for release builds, where you don't want to include any debug info in your release build so that your binary ends up smaller. But where this gets tricky is that the standard library in Rust is pre-compiled. It ships like from Rust to your computer with debug info in it, but also built in release mode. And so in your final binary, when you link the program you built with the standard library, you now end up with a binary that does still have some debug info in it, even though you specify debug equals 0 in your cargo toml or cargo config. And so the change that happened in 177 is that now by default in release profiles, which have debug equals 0, it also now sets strip equals debug info. So again, this is not a change like whenever you set debug equals 0, it's specifically in the release profile that ships by default with cargo. It will now strip the debug info from your entire binary, including what comes with the standard library. You can opt back into it, but that's sort of the change that landed.
Mm-hmm. Well, I believe the release profile already had debug equals 0. This is just for the standard library stuff.
Yep, that's right. Yeah, so it already did have debug equals 0, but it would still keep the debug info from the standard library. And so that's the thing that's now changed.
You often see in people comparing the size of Rust binaries. They're like, I want to make a smaller Rust binary. The first thing you always do is you use the strip tool in your environment. I'm not sure what it's called on Windows or Mac or whatever, right? But it's called strip in Linux, and you just kind of just cuts out all the text sections that probably aren't needed. It made generally real drastic improvements to binary size, but improvements if you don't want that info. If you do want it, then keep it around, right? That's why it's there in the first place. So this kind of does it by default. So it's a nice little. It should hopefully result in some people writing blog posts about Rust binary size to give Rust less of a hard time.
Well, I think in past releases too, we've talked about this idea of split debug info, right? So the debug info going into a separate file, which obviously also helps with this in a less severe way.
Mm-hmm. Which I'm not sure if that's that's like how it works by default on Windows, and I think Mac it is now supported. I'm not sure how well it's supported on Linux.
Yeah, I don't remember either.
We should be reading the chat here too. They give us nuggets of information, right? I want to call back to the previously. I mentioned before that I said maybe it was Golang that always allocates a null after every string. Someone's saying that's not Go. So I'm not sure which language it is, but it's some language out there that does this. It's hilarious, right?
I think we're then on to stabilized APIs. Ooh, we have a core net module. What's core net? Oh, this is just all of the IP stuff that has moved into core. Is that right?
Right. And so, well, it's not like, it's not about, doing the idea of core versus split is that, core is the thing you don't need an OS for. And like one of the things you need an OS for is like, networking, probably. You probably don't have like, a driver for a network card in your like bare metal OS unless you want to provide it yourself, right? And so, but these are the types. And so this is what, if you are writing an OS in Rust, say, this is what would let you write your own, module using only core, your own networking library using only core is compatible with the rest of the world of things written in Rust. And so yeah, it's just moving the types here.
Yep.
Which is
and
cool.
presumably
I think,
because
more things should do this.
Well, like the IP address type, right, has nothing to do with the OS. It is just how to turn like a U32 into an IPv4 address or a U128 into an IPv6 address.
Mm-hmm. So like we're not here to open sockets. We're just here to turn a tuple of some U32s into a struct of U32s effectively.
Yep.
So yeah, I definitely at my job we definitely took use of this because we are implementing. You have a no stood thing where we implement a network stack. So yeah, it's cool.
Nice. I think we also have a candidate here for a pretty obscure function, which is F32 round ties even. If you have an F32, you call this function in order to round numbers such that a number that is exactly halfway between one integer and the next gets rounded to the even of those two integers. That feels pretty specific to some use case.
The idea of rounding in floating point is like difficult in the first place. There's all kinds of like, quote unquote wrong ways to do it. If you have like care about like, statistics, it's like, well, if you always round down, then like your negative numbers are going to be a little bit lower on average than your positive numbers. If you always round towards zero, then, okay, well, depending on like, the vagaries of how floating is represent, it might, have like something. And so I think, this, I don't know the exact, reason behind what this specific way of rounding provides, but I think some people really want this. So
yeah, I'm sure like there was probably like a demand for this. I can't think of the use case, but I'm sure there is one. We've also got another cool function that was added here, which is clear poison was added to mutex and RW lock. And the notion of a poisoned lock is something that Rust has where if a thread panics while it's holding a mutex or a reader-writer lock, then the mutex gets poisoned. And if you try to take a poisoned mutex, then you also panic. The idea here being that, if a thread panics while holding the lock, who knows what state the data inside of that mutex now is in? Like the thread might have, let's say you have a mutex over some struct that has two fields, and the thread updates one of the fields, and then it's supposed to update the other field to be consistent with the first, but it panicked in between. Then now, it releases the mutex, but because it panicked, the mutex is in an inconsistent state. And so the idea of poison is to make sure that that sort of idea of the mutex now being tainted moves on to other threads, and that if they try to access it, they also panic instead of doing something wrong. The thinking behind clear poison for this is if you have something that detects that a mutex has been poisoned and then realizes that it has some way to recover from that mistake, it can like put the state in the mutex back together into consistent state, it can then call clear poison on the mutex to indicate that you no longer need to have threads panic when they take this lock anymore because I've fixed the state. Which previously I think was just not possible. Or maybe you could replace the mutex with a new mutex, but that's not always an option. So this seems like a nice sort of ability to do something we couldn't do before. We've also gotten a helper for file. So on file, you have the create method and you have the open method. So open is open a file that already exists, and create is make a file at this path. But create has this weird property where it's sort of a create or overwrite. Like if a file already exists here, then create a new empty file there and sort of truncate the old file. And if no file exists, then make a new one. But what this new method create new does is it will only create the file if it does not already exist. So it will never truncate an existing file sort of accidentally, if you will. It was possible to do this before. So there's a type in the standard library called open options. I think that's the name of it. Yeah, so if you call file : options, you get back this type called open options that allows you to configure how a file should be opened. Things like, should we error if it already exists? Should we truncate a file if it already exists? A bunch of different properties you can set for the file open. And so you were able to do this, but it required this like really long chain of builder methods on open options to get it. And so now you just have a simple helper method to say, I just want this file to be created and I want it to be an error if that would overwrite something.
I think also the important thing here is that it might not be possible to actually do this right now, where the intent of this method, I believe, is to prevent the case where you checked if the file exists and then the file suddenly exists and then you open it. Right?
So that is still possible with file options. So with file options,
so with create new is designed to prevent that, and so it's atomic.
No, that's not what I mean. So with file options, you can achieve the same outcome.
Oh, can you?
So yeah,
okay.
So with file options,
the file doesn't exist, and it'll like stop it. If you get a negative result, it'll stop it from existing.
So file options is more like you configure the single call to the kernel that's going to do open. So it's not a sequence of things that you do. File options is more like a builder for the one call to open that you will do. So you can do, file : options, you get back in open options. And then you call .read true, .write true, .create true, .truncate false, and then .open. And then that final call to open is like a build, and that is the one atomic point where something happens or doesn't happen. And then there's a bunch of chunking methods on slices that I don't think are too interesting to talk about. They're useful if you need them, but I don't think it's worth diving too deep into. So I think we're down to the changelog then.
While you're looking at the changelog, I want to kind of go through the here on Reddit before we're talking about, what is offset of good from? Someone here is saying, their use case for offset of is they need to make sure that the structs that they define match up with some spec in something they're using, and so they have assert offset of. Is like, they guarantee that the offset that they expect is what they think, and then you can, because asserts are now usable in context these days, these could be compile time asserts.
Oh, that's really cool.
And so, yeah,
looking at the changelog, one of the things that came up was to disallow references to static mutes. And this, I think, puts on all of Ben's alarm bells when it comes to static mutes, which is a static mute is a static, so it's completely global state that is also mutable. So you have mutable global state, which is awful in all sorts of ways. And one of the things that's really interesting when you have a static mute is that it is always unsafe to access, right? Because it's global mutable from any thread, so it has to be unsafe. But it's interesting because it's undefined behavior to even take a reference to a static mute. Because the whole point of a static mute is someone can just mutate it out of nowhere. It's global. And that means that taking a reference to it could be immediately undefined behavior if someone else is modifying it, even if you're not reading from it. And so I don't know whether this landed as a thing that will happen only in the next edition or whether it actually landed in 177 like the changelog seems to indicate.
Warning that landed.
Yeah, so it might just be the warning.
Doing this?
Yeah, you should never be doing this.
I mean, if you are a binary crate and you can guarantee that you never use threading, so the invariant, so it's unsafe, the invariant you need to uphold for unsafe static mute, whenever you access them, is that there must only ever be one thread in this process, right? And so the only person who can possibly uphold this is the binary. If you ever read a library with static mute, don't do that.
Yep. Especially if it's a mute that's also no mangle. Yeah. Then you're just setting yourself up for failure. But so I thought it was just an interesting observation that even creating a reference to a static mute is very often just like instant undefined behavior. And so that is at least now linted against, if not outright denied, or at least it will probably be denied in an upcoming edition.
And to be clear, right, the idea is that if you need static mute and you need to actually whenever you need it for, I need this, right? There are alternatives that aren't static mute, right? There are patterns, right, where you can have a version of unsafe cell that is just like sync, right? But that can be static, right? And then you just put that in a normal static. You don't have a static mute. You have a static, and then you can do the usual unsafe cell thing to better uphold the invariance and take references to it, because that's safe. That's guaranteed to be safe.
And I think there's even a nightly only type, at least for now, called sync unsafe cell that is specifically for this kind of purpose.
Yeah, if you look back on the deprecate static mute issue in Rust, which I might have been the one to file 10 years ago. the answer is, hey, people are kind of like, hey, well, I need this though. What can I do instead? And people are kind of talking about, hey, there's this idea, this thing called sync unsafe cell. We could just use this, and then we should have been shipping it years and years ago. But those things that nobody ever gets around to. So I think for a long time people were waiting for for a long time we couldn't static constructors and statics were anemic, and so we couldn't do but for a long time we couldn't do foo : new. Because there weren't const fns back then, and so it was kind of like, well, until we have const fns, there's no point in trying to pursue this. And so
it's like there's a whole chain of dependencies until it becomes actually realistic. This next one I thought was interesting because I think it's the first time I've seen an example of undeprecating a lint. So there's a lint called unstable features, which is specifically intended to indicate that you should not be using unstable features in your code because they are unstable. They only work on nightly. And this lint was being deprecated because, well, I think it was just implemented in the compiler that you can't call unstable features when you're not on nightly. It wasn't really a lint. But now they've decided to bring it back as a lint because there are some of the crates in Rust C that they want to compile on stable because they're used by Rust Analyzer, which has a no nightly policy.
And they want to deny it then?
So they want to deny unstable features in this crate, but they need it to be a lint because Rust C Bootstrap is set to 1 for the Rust build. So it's very easy to accidentally use unstable features in those crates. And if you did, it wouldn't be caught by Rust CI, but it would end up negatively impacting Rust Analyzer. Okay. And so they want to bring this lint back and then deny it in those crates.
That's kind of funny, yeah. I can see it. I mean,
compilers
at Bootstrap are weird and a pain in the butt in many ways.
Yep.
So.
Yeah, specifically, it's like the Rust C Lexer and the Rust C parse format crates that are used outside of Rust C, like by Rust Analyzer. And then there was another, and this one has a bunch more history to it that people can dig into if they're curious about it. And I think you were part of this discussion too. I think I saw your name mentioned here somewhere, which is always a terrifying thing to say, but we'll see. So this is deny braced macro invocations in let else. So specifically, the thing to deny is if you have, we talked about let else earlier, but the idea is that if you have something like, let pattern equals expression else diverging branch, the expression is not allowed to be a macro invocation that uses curly brackets. And in particular, the idea here is that the original RFC for let else said that the expression in a let else is not allowed to end in a curly bracket. And the implementation in the compiler until Rust 177 disallowed all sorts of contracts that end in curly brackets except for macro invocations. And so now this finally sort of closes the hole and also denies braced macro invocations as the expression in a let else.
Yeah, so for the reference, if you have a macro, a little known Rust tip is like, say the vec macro, right? The vec macro making a vec. And vec, exclamation point, square bracket, right? It's like a square bracket, like an array, right? But macros don't care what bracket you use. You can do vec, exclamation point, parenthesis. You can use vec, exclamation point, curly bracket. It's all just a matter of convention, right? There's no actual enforcement of any of this. And so, there's never a case where you need to invoke a macro with curly brace. It's kind of, you can always use a different bracket there. So I'm not sure. I'm sure there's some parsing reason to do this. The Rust kind of in some ways does bend over backwards to make to do things with brackets. And so, for example, I think there's some weirdness in the Rust grammar with regard to if and struct literals, where maybe you can't use them together in certain ways unless you do a certain thing, put parentheses around it. Maybe that's been lifted years ago. I don't even know. But back in the day, 1.0, it was kind of oh crap, our grammar's ambiguous with regard to if and then some struct literal happens. It's kind of we just got to get rid of this. Just to require parentheses around it. And so there's been it turns out keyboards just need more bracket types, right? Only 3 is not enough. Angle bracket's not even enough. We need more than that.
Well, so clicking through this one a little bit, I got to this comment by David Tolnay, and it says, based on a suggestion in Zulip by Beastry, shortly before the publication of this RFC. So who knows? But I think the long and short of it is that one of the reasons why they want to disallow any expression that ends with a curly bracket in let else is so that it is always possible to distinguish when you look at the else clause whether this is an else for an if or an else for a let else. Because if you disallow,
could be if.
Right, exactly. And how to read the else branch really differs depending on whether it's a let else or the else for an if. Because if it's an else for an if, you know that the code is going to continue executing after. But if it's a let else, you know it's going to diverge. But if they both start with end curly bracket, else start curly bracket, just as a human, it's harder to understand what's going on from a glance. And so that, I think, was one of the primary reasons.
Let some foo equals if, and then suddenly dun dun dun.
Right. Yep.
Have an else in the end. And so yeah.
And so this is where the original RFC just said no ending curly brackets in the expression, and then over the sort of time since the RFC landed, there've been a bunch of changes that limit what kind of expressions you can have in there. But there was been like disallow block expression, disallow loops, disallow conditionals. But ultimately, there was nothing that captures like anything that ends with a curly bracket. And so macro invocations were missed as a sort of missing case there that are now finally denied in 177. And then, so 177 is when we finally got support for cargo : which we talked about ages ago, almost half a year ago, Ben, if you remember. The move from cargo with a single colon until cargo with a double colon for cargo instructions from build scripts in order to allow them to extend the set of invocations that you can have from build scripts. So that landed in 177. I think that's all I had for 177. Do you have anything else from the Reddit thread?
So I talked before about some of the supply chain security, stuff that's kind of like moving through the world of programming. And apparently in this one, cargo metadata now uses the same format as cargo package ID for identifying packages, which unlocks passing IDs to other cargo commands and cross-referencing this data within the cargo.lock file. Apparently,
this is one of the PRs I had open. It was like, it's not worth talking about. But I guess if Reddit is excited about it, we can talk about it.
75 people upvoted this.
All right. I'll take it on.
The ecosystem is, I guess, standardizing on things, so it's nice.
It's pretty fast to talk about. So Cargo has traditionally had a couple of different ways to name a specific version of a specific crate that were used. Like there was a different way to specify that in the output of Cargo metadata and the input of Cargo commands and what appears in lock files. They weren't all like fully aligned with each other. And with 177, all of these now use the exact same format for describing a specific version of a specific crate in your dependency graph. And so by making them all have the same representation, you can now like read an ID out of cargo metadata and pass it into something like cargo update-p, and it all just sort of works because they're all the same format.
And then with regard to the new stabilized APIs, some of the slice stuff, I saw someone be excited about those. Let's see. So chunk by and first chunk. Oh yeah. So this is stuff that I think used to be in iter tools, and now it's sort of in the standard library. So chunk by, for example, on slice takes a predicate function and it returns an iterator over the slice, producing non-overlapping runs of elements using the predicate to separate them. Oh, I see. So it like iterates over a slice and uses the function to check adjacent elements, and if the function returns false for two adjacent elements, then it considers everything up to that point a chunk, and it considers starting there a new chunk. It's only for adjacent things, and so it's not like doing a pass over first and then coming back and doing it. It's still all in memory, single pass.
I think so. Yeah. I'm not sure what it's used for though. I guess you can use it to find runs of elements, right? Like give me all the numbers that are sequences of numbers that are the same in this slice.
And then I guess, first chunk on slice, it says, array first chunk obviously behaves similar to array split at, actually array split at checked, but is great for avoiding try into casts when you're going from slices to arrays. So.
Oh, interesting. Oh, I see what this does. Okay, so this is a method. I'm excited about this now too. So you have a slice, you call first chunk on the slice, and it's const generic over some n. and it gives you back a reference to an array of the slice item type of length n or none. So it's an option of that. And so if the slice is at least n long, then it gives you back an array reference of that length. Otherwise, it returns none. And if you were to do this with the array from slice instead, what you get back is or rather in the try from implementation that exists on arrays from slices, you get back a result instead. And so you would need to like unwrap the result rather than getting just an option straight away. But I mean, I don't care that much whether I get a result or an option, I think. They're both the monad, so I think we can move on then to 177.1. We got a point release.
We have 2 point releases for this.
Oh, wow. Okay, the first one is
there are
that
features in 77, so it's natural.
Yeah, 77.1, it looks like it doesn't work on Windows or was broken on Windows with the MSVC toolchain. Yep. Debug stripping does not behave in the expected.
Too strong.
It says debug info stripping does not behave in the expected way on Windows with MSVC. What does behave in the expected way?
It might have totally broken in backtraces on Windows, or only MSVC, that is. So. Oh
yeah, it does look like it broke backtraces for Windows.
Which is funny because like Windows has a split debug info to begin with, and so they don't even really care about stripping it.
That's interesting. Okay, so 77.1 just disabled the new cargo behavior on Windows for targets that use MSVC. Great, so that one's straightforward. And then we got 77.2. This was a CVE fix. Okay, there's a little bit of context needed here. So in general, when you spawn a process from inside any language, but when you spawn a process, the way that you do so is OS dependent. And the way that you pass arguments to a program that you execute programmatically is also different depending on the platforms. In C, on I think all platforms, it goes via, or at least on Linux, the way that you pass arguments to a program is you put them in this particular part of memory. When you execute the thing, in the system call to Linux, you pass in the arguments, and Linux makes sure that they end up in a place in the memory of the newly created process where libc knows to look for them. And crucially, it's an array of string pointers. This means that the arguments have well-defined boundaries. So if I pass 2 arguments to you, it's not as though they're like white space split or something. They are 2 separate pointers to string literals that end up in my address space. And so I can clearly tell what is the first argument, what is the second. On Windows, specifically for certain kinds of executables, like specifically things that need to be invoked via cmd.exe, so things like bat files and cmd files, those you have to execute through cmd.exe, which means you have to pass the arguments as a single string. And then you have to escape them so that they match the argument splitting logic of cmd.exe. And it turned out that the way that Rust was escaping the arguments specifically for BAT and CMD files on Windows was slightly wrong, such that an attacker could inject arguments that caused cmd.exe to execute arbitrary code. So it was like potentially pretty bad if you were passing arguments sort of blind trustedly from users into these kinds of programs on Windows. It was fixed. There's a bunch of write-up about why this happened and the kind of escaping that's needed and some of the subtleties around exactly when it triggers. But the fix in 77.2 was not really to fix the escaping to make it perfect, but rather to acknowledge that sometimes the escaping can't be perfect, and then we will actually issue an error when you try to execute such a program, rather than allowing it to go through with potentially some things being unescaped. Oh, someone in chat is saying that Windows is always a single string for the arguments. It's just that the escaping logic for CMD is just different. That's even worse and scarier. So depending on whether you're executing a command and bat file or just executing some other program, you need to escape the argument list differently. That's rough.
Strange.
Seems bad.
Yeah, I mean, like, I wouldn't mind, the whole idea of having your arguments be a single string honestly sounds kind of nice sometimes. user behavior like isn't like bad, but it's kind of like annoying that they're just like white space limited, and so you have like X, Y, Z, you get 3. If you say X equals Y, you get 1. That's kind of a pain, and so you'll have to manually parse your stuff. And so I've wanted sometimes to kind of say like don't worry about parsing this yourself. Just like give me the actual full string. And so, but you definitely want to make sure that all your parsing is agrees on what actually is an argument and not. So
yeah, it sounds painful though to have to mirror the escaping logic, right? Because we don't control what Windows does, so we just have to mirror what they do on the de-escaping side. That sounds like a losing battle.
Yeah, well, it sounds like they should provide, if they care about escaping, they should provide an API to escape a thing safely.
Yeah, you're not wrong. I think that's all for 177.star. I think we're on our last Rust release. Is 178, did we say we were going to do that as a new episode?
I'd say just do it as part of the same one, unless you want to come back and tack on.
How about we brand it as a bonus thing in this episode?
Bonus.
Yeah, so we go something like, you think this episode was supposed to be over, but wait, there's more. We have decided to be so gracious that we are including...
You come out on stage in like a turtleneck and you say, actually, there's one more thing.
Just one more thing.
1.78. Our biggest Rust release notes podcast yet.
That's right. May 2nd, a new thing hits the world. No one could have seen it coming. It is going to change everything.
I do like the idea of there being kind of like a random oracle that eventually just cuts releases randomly, just says, aha, this is now the release. And no one knows when it will ever happen.
We should have it just be the Fibonacci sequence.
So what's the 78th Fibonacci number?
Yes.
Well, we can ask Rust. I'm sure Rust knows. Yeah, this is now an interview, John. I want to see your ability to code Fibonacci live on stream. Find me the 78th. Okay.
Wait, no, damn it. Not what you wanted. See, this is how you fail. That's how you fail.
Yeah. Clearly.
Oh boy. See, this is how real programmers do it. Fibonacci number compute Linux bash.
We're gonna do it in bash. It'll be blazingly fast.
Fast?
Yep.
Well, I need to have it be a bash program because how else would I pipe it out so that I can get the 78 number? Wow. N is just hard-coded. See, I made it dynamic for you. Boom. Right there, Ben.
Okay, so let's assume every number is 1 day. So how many days is 5527939700884757?
Oh, that's easy. Google knows this one. Days in millennia. It's only that many millennium.
Okay, great.
Have I helped you now?
Ages of the universe.
That's right.
It might be a while until we get it's a shame because inline const was just about to land. Oh,
yeah, I know. Oh, we missed the train. We have to wait another. Damn it.
We have to wait another 4 billion ages of the universe.
That's right. Oh, you're right. That might be Fib 77. It's okay. That just means that it's worse. The last number is
the 78 episode.
I was gonna say the last number is left as an exercise to the reader. So Ben, Rust 178. This one I actually think is pretty cool. This idea of diagnostic attributes. Do you want to talk about this one?
Yeah, sure. So, okay, it's actually I'm not sure. I'd love to know what other languages have a thing like this. And so, for example, in Rust right now, right? So normally, if you're writing a proc macro, and so a thing that runs compile time, if you have like an error, oops, I panicked my proc macro, it's going to print that as a compiler error because it literally is a compiler error. It's a thing running in the compiler's address space, right? And so there are ways to customize whatever compiler error you want to give the compiler. And there's also ways of doing it beyond out of proc macros too. There's the compiler error macro, which if I forget how you actually use this. Let's see, let's look it up. So the macro compiler error. It says it causes compilation to fail when encountered. So it's for conditional compilation, right? So if you have a conditional compilation branch and you want to hit a compiler error when you hit this, right, you can do this. And so, for example, if say you had compilation or conditional compilation on like certain platforms only, say you had like, your crate contains like an assembly block, and you can't, predict the assembly for every platform in existence, and so you only have, assembly for Mac and Windows and, I guess, x86 and, ARM, right, say, and someone tries to run your crate on a totally random architecture, you could just say, hey, like, we are configured to give you a compiler error rather than kind of like just like failing or the totally bizarre, obscure kind of assembler error. And so that's a cool thing. Right? The idea that Rust gives you the ability as a library author to customize compiler errors is great because, Rust, like, right, you catch so many errors at compiler time. Normally, things that you encounter at runtime are now at compiler time. And so if you want to give a nice experience, you want to be able to customize these things if you're a library author. And so in this case, it's a new way of customizing the output of the compiler, where anytime that the compiler would emit E0277, which is whenever you're trying to invoke a method from a trait and the type that you're using it on doesn't actually implement that trait, you can now customize the output of that message. And so it's kind of done in a generic way, right? And so in the future, they could add more things like this to the diagnostic attribute here, which is super cool. I think this is like again, I'd love to know what other languages are doing this, or if Rust is kind of like on the forefront of just like giving users the ability to customize compiler output, because it's super great. I love it a lot.
Yeah, and I guess to describe this sort of for the audio audience as well, the idea here is that there's a new attribute called diagnostic, and diagnostic is always suffixed with some name that is a particular type of diagnostic. So the only one that's currently being stabilized is the attribute diagnostic : on unimplemented. And it's an attribute that you put on a trait, and it lets you customize what errors someone gets if they, as Ben said, tries to use a method from that trait on a type that does not implement that trait. So it lets you customize that message rather than getting just the generic, the trait bound, whatever implements trait is not satisfied. And the idea here being that you might be able, for a given trait, to give more help to the user about what it means not to implement this trait, or, things you might not have thought of, or things that often need to happen in order for something to implement the trait. And the hope is that over time, we might get other sort of variants of these diagnostics that you can put on other things like types or methods or something that allows you to further augment the output that you get from compiler error messages that are related to that type or function or trait or whatever it might be.
Yeah, and I will steal the example provided by Reddit here, which is kind of imagine you have an API where the user is supposed to implement a helper trait or a kind of like, a side trait, and then there is a blanket impl somewhere that implements some other trait for any trait that implements that side trait. And then you try to call a method on a random type on the original trait, not realizing that you have to implement the side trait, right? And so this way, the error message can tell you, hey, actually, it looks like you're trying to call this method, but you need to actually, if you want to use the API properly, implement this method over here. It's totally random other method, and then this blanket impl that applies over here will give you this for free. And so, yeah, it's cool stuff.
Yeah, and the other example that's given in the changelog is for the sized trait, which the compiler already does something like this. It doesn't actually use the diagnostic attribute, but it sort of could. And the idea here is that if you have a type that doesn't implement sized, the compiler actually gives you a message that doesn't just say this type doesn't implement sized. It says the size for values of this type cannot be known at compile time. And then, it indicates the particular type and says this type doesn't have a size known at compile time, which is specific to sized, right? You couldn't output that message for any trait implementation except for sized. And so it's a customization of the error specifically tailored to the trait in question. It's important to point out, though, that this is not a thing that's guaranteed to happen. It's intended to be a sort of hint for the compiler or advice for the compiler about how it could improve the error message. The compiler is not required to actually take this diagnostic into account. There's another cool thing that I think is added in Rust 178, which is the ability to assert unsafe preconditions. And there's actually a little bit more history here. Do you know more of the history for this change, Ben?
I mean, I'm not sure. I'm not sure this lets the users assert. I think this is for assert that happens in library. We mentioned before previously about how for the in the strip discussion, how standard library is not shipped as a thing that you compile within the users like a dependency. It is shipped as a binary, right? And so it means you get whatever settings are compiled in whenever they compiled it. And so here's the thing, so an assertion is code that runs at runtime and then panics if it fails, right? The idea is to uphold your invariance, and we need to make sure for sure that this thing equals this thing, otherwise just bail out because things got horribly wrong, right? But assertions are usually a runtime cost, right? There's a branch there and a check, and so if you want to have just have an assertion that only in debug mode, there's a thing called debug assertion. Or debug assert, right? Where it is a macro like assert, but inside the macro it also says, hey, if we're in debug mode, just become a no-op entirely.
In release mode, you mean?
Yeah, in release mode. And so the macro will be like, hey, so it'll compile away in release mode. And here's the thing, though. So the standard library contains various debug asserts because it wants to be fast and only test things in debug mode. But the thing is, most people only ever run standard library in release mode because it is being shipped as a binary to end users, and so it's almost never being used. And so this is a cool thing. It looks like where the check for debug mode, rather than happening at compilation time, like when you actually go from source code to a Rust archive, actually happens at code gen time now. And so you can have a library with debug asserts compiled in release mode, but those will be compiled out if the end user is in release mode, and left in if the end user is in debug mode. And so there is still no runtime cost if you don't want to have them in release mode, but you can now actually ship a library that does this. And so that's the background here.
Yeah, and I think they're only really doing this for the standard library for now, at least. It's not a general purpose thing that you can use for your libraries, at least as of yet. But the tie-in here to unsafe, which is what's mentioned in the changelog as well, is that a lot of these debug asserts are specifically for a lot of Rust's unsafe functions, where there's actually a bunch of debug asserts in the standard library code specifically for the unsafe functions to try to check some of the safety invariants that those functions assume of their callers. Things like, this is not past the null pointer, or this pointer is aligned to match the alignment of the T that you pass in. And those things are not, they don't want to check them at release time because doing so would add a bunch of overhead, but they do, it's sort of a nice sanity check to have. And so now, as Ben says, it'll be really nice to now be able to have those assertions be run, those standard library assertions be run when running your code in debug mode. Well, one thing I thought was really interesting about this, I highly recommend taking a look at the PR that implements this. For those following along, it's PR number 12594, just to see how this was moved from being just a straight config ! Debug assertions into something that happened at codegen time, because the way it actually happens is through they introduce another intrinsic, which does get expanded at codegen time. And so it's a really neat trick essentially for making this happen that I thought it was pretty fun to read through the actual diff of. Do you think this is something that we might get for libraries that are not the standard library, Ben?
I'm not sure. Well, right. I'm not sure if it doesn't currently happen. I just think that normally, because you treat Rust libraries as source, it doesn't really matter. I mean, you can imagine maybe somebody is like, I do want to attribute my library as a binary, in which case it might matter. Right, because I think for now, if you are compiling from source, it doesn't have any actual there would be any difference between generating them at compile time versus at code gen time. So,
but once we start having people cache cargo dependencies, for example, and provide pre-built cargo dependencies on crates.io, which I'm sure is right around the corner, then this would matter.
Mm-hmm. Right, and I suppose so there's a thing, right, where if you are making a library and you have some dependency that's just really slow in debug mode, it's some crypto crates where you always want to have them in release mode because otherwise they're really slow, then normally in Cargo.toml you would say, hey, I have a profile where for these crates, these dependencies, always put them in release mode, no matter what mode I'm in. And in that case, I'm not sure what happens. I assume that if they had debug assertions, they would be turned off.
Yeah,
it's kind of
I think so.
Right. So yeah, I'm not sure today what happens. I don't know. I mean, it seems like if it works for standard library, I don't see why it wouldn't work for everyone else.
Yeah.
Maybe it does. Maybe just they don't mention it because it's kind of a rarer use case. So it's worth trying out.
Yeah, because the trick, at least as far as I understood the PR, is really to add an intrinsic. So just a function inside of the std or core intrinsics module.
Inside of debug assert though, which I assume Rust is still using the standard debug assert.
No, so it's a slightly different thing. It's an intrinsic function that returns a bool but the bool it expands to is checked at codegen time. And so in theory, it's a const fn, and so it's something that you could call like instead of using debug or if config assertions or debug assertions, if this intrinsic was stabilized. I think you could call it in your own libraries too. It's just I don't know that there's currently any plan to stabilize this intrinsic.
Right. Well, I mean, as long as the assertions they're talking about here are using the debug assert macro, I don't see why they wouldn't apply for anyone using it as opposed to just standard library. But I mean, like, there's an example here in the.
They don't.
Say, hey,
so in the standard library,
they're from raw parts, right?
Yeah,
so
but they're not using debug asserts, I think. So my read of this is that in the standard library...
It's a thing called assert unsafe precondition.
Yes. So there's a specific helper in the standard library that's used to check these, and it's the helper that's been updated to use this intrinsic. It's not the general debug assert eq or debug assert set of macros.
I see. Okay.
Although,
right.
in theory, they could be extended to those. It would be interesting to see that too. The next change we have in 178 is deterministic realignment. This one I know very little about. I think my understanding here is this is mostly a documentation change where previously Rust wouldn't commit to certain guarantees, but now they have. Do you know anything more about this one?
Well, I think, in const mode, so the idea here is that for various reasons really to do with, soundness and type safety, const contexts, right? They need to have the same semantics as runtime context, as non-const context, because you might use the output of a const function or something as the type, or might end up somehow in the type signature of a thing that gets run at runtime. And so if you compute, run these run one compile time, run one time, and compare the results, they should compare equal, otherwise it could be type unsafety, right? And so as a result, const compilation has to be kind of very conservative, and I think that this was a case where const was just being too conservative as a kind of a defensive measure. Let's see, I'm trying to see. These caveats primarily existed as a hedge against const evaluation, but they're only stable for non-const use anyway. So the idea is that they were previously being conservative because they were worried you might use these in const context, but they're kind of like, actually, let's not allow them at all in const contexts. So
yeah, I think there's an example here of the pointer align offset method or function method, I suppose, which is a method on a pointer where you give it an alignment and it tells you how off the pointer is from that alignment so that you can then add to the pointer to make it be aligned. And it actually specifically says if it's not possible to align the pointer, the implementation returns usize max. But then it also says when this is called during compile time evaluation, which is unstable, the implementation may return usize max in cases where that can never happen at runtime. So this is, I guess, somewhere where it sort of diverges between const and non-const context, because in const context, you might not know, and therefore you have to return it's impossible. Whereas in runtime context, you will know, and so you can return a definite answer. Interesting.
Right. So I think this is mostly kind of if you're doing some strange things, you might care about this. Other than that, I think it's not really that big of a deal.
Yeah, I think that's probably right.
Other things that are more interesting.
Someone points out in chat about the previous thing on debug assertions that opt levels and debug assertions are separate settings in the profile. So you could compile your dependencies with opt level 3, for example, but debug assertions still on.
Right.
That is a thing you could do.
That's true.
But it would be nice if you didn't have to, right? If you could just say full optimizations, but you still got all of their debug assertions. Because the thing I guess you have to be careful about is that debug assertions could be pretty expensive, right? That's the reason why they're debug assertions. And so it might actually be like if you included them in a release mode build, the resulting release mode build might still be too slow if the debug assertions were on. Just because they're like expensive to compute, for example. Which I know is one thing that they were worried about for this change in the standard library was sort of to make sure that all of the things that use this new feature aren't things that end up being too slow in the consuming code, like things that use the standard library methods. I think we're then on to stabilized APIs. And I actually don't think too many of these are interesting. Most of them are sort of smaller things. Are any that stick out to you?
So the question for impl read for reference to standard in, I guess the question is, why doesn't it already exist? Like, what took us so long?
Yeah.
For kind of an oversight?
I think it was because there's already an implementation of write for a reference to standard out. So it feels pretty obvious to impl read for reference to standard in. The only thing I can think about is that it has to take the standard in lock each time, but that should be the case for standard out too. So that it feels like just an oversight. The other thing that was added here is there's a bunch of trait implementations for the standard library error type that just accidentally didn't specify a lifetime specifier and therefore got assumed to be static when they didn't need to be. And so a bunch of those have been sort of loosened up to allow returning boxed in errors, for example, with arbitrary lifetimes as opposed to specifically with a static lifetime. And I think this is related to the fact that when you write boxed in and then a trait, if you don't specify like plus tick lifetime, then the compiler infers that to be plus tick static. Unlike everywhere else in Rust where if you don't specify a lifetime, it means it doesn't have a lifetime. For boxed in, it specifically means this thing is static. And so that sort of relaxation of a requirement is probably useful to someone, although I don't immediately see where you would specifically want a non-static error, but I'm sure there are some. Someone's saying that the intrinsic that the standard library uses in core.
Well, right. So core intrinsics is almost all unstable by design, right? So
yeah, but it's not.
There, it might be usable, but
yeah, it's not even listed as being. Oh no, it is. Assert unsafe precondition. The core macro is in nightly only. I wonder if the intrinsic it uses is as well. Core intrinsics. No, it doesn't look like it. The underlying intrinsic is not. Just the sort of helper that the standard library uses to express unsafe preconditions. And then in compatibility notes, this is another release where Rust is increasing its minimum requirement for a bunch of targets, specifically Windows this time. So with Rust 178, Windows 7 and 8 and 8.1 are all unsupported. So the minimum requirement for Windows is now Windows 10. And I want to talk about that for a sec because there is an interesting thing when I started digging into the release notes that I thought was neat. So first, in the detailed release notes, one of the things that came up there is a replacement of the implementation of reader-writer locks on Unix systems to not use pthreads, but instead use a custom implementation. So they've written basically a faster reader-writer lock that uses thread parking and unparking under the hood, but other than that does not interact with some OS level thing like pthreads, because the performance characteristics of not going through pthreads are actually quite good, and you get rid of some of the limitations of pthreads, like having to box the mutex or the reader-writer lock. On Linux,
kind of like futexes?
Sort of. So on Linux, you can use futexes, but on like generic Unix, there is no such thing as a futex. And so there it fell back to pthread mutexes, which are generally just worse. So this is actually a custom implementation of a reader-writer lock using like a intrusive queue. And I think it's based on the Windows design of slim reader-writer locks. But it's just it's a custom implementation. It's actually pretty cool to read the code. It's pretty well documented about how the algorithm works, but it truly is like implementing a reader-writer lock algorithm from scratch. The cool thing about this is that it enables us to use non-pthread reader-writer locks in all Unix settings. And in fact, all it really requires is that you have access to thread parking and unparking. And so one of the things they were able to do with this change is actually improve the Windows 7 and 8 and 8.1 reader-writer locks, because one of the things they did in 178 was to switch the Windows implementation of mutexes to use a newer, better version of mutexes in Windows that's only available in Windows 10 and onwards. And people were worried that this meant that the reader-writer lock and the mutex on Windows 7, for example, would just be bad forever because it has some like known deadlocks and such. But because they had this improved reader-writer lock that only relies on parking, they could now take that implementation and also use it for the older versions of Windows. And so now the older versions of Windows, even though they're unsupported, still get a better reader-writer lock. But the reason I went down this path is because this example of moving the Windows mutex to a way better implementation that relies on APIs that were only standardized in Windows 10 is the example of why it is so important for Rust to be willing to drop old versions of targets over time. It's because if you were stuck with, we have to support, every target we've ever supported, not only is it hard to test for, but it also means that you can't as easily make use of these new APIs and new improvements because you need to keep all the sort of backports and fixes around, including things like working around broken implementations that might exist in certain versions of the operating system. So this is a cool example of Rust making use of a newer version of a target, and also an example of being able to re-implement a primitive and using it across multiple targets afterwards. That was a long rant, but I thought it was cool.
Yeah, that's not even the only compelling note here, which is the Rust 1.78 has upgraded its LLVM to version 18. Okay, there's another thing here, which is that talked about ABI previously, where an ABI is how this library knows how to talk with this library if you call a function between here and here. And I mentioned before that kind of there is a de facto ABI for C. That both Clang and GCC agree on. There's actually a lie. Gankra has a great blog post, maybe even two, about how ABIs are a lie and a big pain. And one of the biggest, most important differences between the ABI for Clang and GCC, even for just compiling C code together, is that 128-bit integers had a different ABI in Clang. Probably, I think everyone agreed that Clang had the wrong ABI, but it took a long time for everyone to agree it was time to break it. I'm not even sure if Clang. I know that. Okay, so Clang and LLVM are pretty tightly coupled, right? And so for a long time, Rust just inherited whatever Clang did because Rust uses LLVM behind the hood. And so I'm not sure if Clang has yet switched to using this, but LLVM now actually lets you use the quote-unquote proper ABI for 128-bit integers. And so Rust has now begun using that. And so Rust has now broken its ABI, which happens all the time. It's not a big deal. And so, it means that there's also a blog post I saw that was talking about someone who was benchmarking and said, hey, now if you were using these integers, now because alignment has been fixed, because previously I think alignment was half what it should be. That now you should be properly aligned if you are actually, and you might result in a 5% improvement if you have heavy numeric code using 128-bit integers. Just one of those little API notes that's kind of a neat little thing under the hood.
Yeah, I pulled up the compatibility table. There's a pretty good blog post write-up, I thought, of this change to layout in 177 and 178.
The Rust blog has one of these.
And there's this giant table of which things are compatible with which things when it comes to layout. And I love that they also include GCC and Clang. So GCC is fully compatible with Clang 18 and above, but is not compatible with Clang below 18.
Oh, yeah.
And it's because of this... I can't find the table now, but there are so many tables. This is a great write-up if you're curious about this. The changes to U128 and I128 layout in 177 and 178. And it has lots of tables about how things are incompatible with other things.
Yeah, and we'll link to Gankra's 2 blog posts about ABI for further reading.
Yeah. The next thing I have is, this one's not interesting, but is that in 178, it became a hard error to have consts in match arm patterns if those consts don't implement partial eq. So this requires a little bit of explaining, I think, especially for the audio followers. If you have something like let's say you just have a usize. So you have a const that is defined to have the value 7. You do a match over usize, and in one of the arms, the pattern is the name of that const. Then that is fine because Rust knows that constant, its value is 7, and so it knows that this is equivalent to a match whose arm has 7 there. It gets more complicated if you're matching on a struct, for instance, and you have a const that holds an instance of that struct. Because now it's not entirely clear how Rust is supposed to check whether the struct matches that const. The goal is for Rust to use partial eq to compare them. What would actually happen in older versions of Rust is that this would be permitted and could lead to really weird results. I'm trying to see if I can dig up the example of this being weird. So the idea here is that we should require that the type implement partial eq, because how else would you check that the value to the match actually matches the value in the arm? And there are actually some caveats to this where what you really need is structural eq and not just partial eq, but that's getting into the future that we haven't arrived at yet. But the general idea here is that there's been a future incompatibility lint on this for a while to have constants in match arms that do not implement partial eq, and now that's become a hard error in Rust 178. So this is an interesting example of something that was a future incompatibility warning, which we've talked about in the past, that do surface from your dependencies, that has now actually become a hard error within the same edition, because it's deemed so troublesome to have code like this, because it behaves just wrong. Do you happen to remember what the issue is when matching on cons that don't implement this?
Not even remotely.
It's frustrating. I feel like I found it earlier and now I cannot find it again.
I'm surprised it ever worked.
Well, it's not too important to dig up. I just, I feel like I found it easily when I was looking through this previously, and then now I'm just not finding it. Like specifically why the forward compatibility thing even existed. But oh well, we can move on. Another thing I found was, and this is just a sort of improvement to the compiler errors that you get. So macro rules is a little bit weird in that, unlike basically every other item in Rust, you have to define a macro above where you use it. And above here meaning literally in the source code file, the macro rules has to be defined further up in the file than where you call it. This is not true for like anything else. You can define function foo and function bar, and function foo can still call function bar, but the same is not true for macros. And this can be really confusing because the error you get is there is no such macro, even if you have the macro right below the place you're calling it from. And so finally in 178, the error output for this thing now got better, and it will actually tell you if there is a macro in the same file by the same name that just happens to be too far down, and suggests that you move it up because that is the way to fix it. This feels like a long time coming. I don't know why we didn't have this until now, but it is a really nice improvement, I think. What else do I have? The cargo team also stabilized the version 4 of the lock file format. So cargo lock files do actually change their format over time. So we have had, well, now 4 different versions of it. And the difference is, like, cargo doesn't like to change the lock file format because it causes a bunch of churn in Git, right? Like now your entire lock file changed just because the format changed, not because your dependencies changed. The reason why they changed or incremented the new lock file format is specifically because they found that the way that they were serializing URLs into the lock file was lossy, or rather it wasn't encoding URLs correctly. And so some dependencies ended up with just the wrong encoding in the lock file. The problem is they can't fix this within the same version, because if they started writing encoded URLs into the lock file, older versions of cargo that didn't know about this encoding would read it out and get the wrong value. And so they had to release a new version of the lock file. It's not on by default yet. The default is still version 3, but it seems like version 4 is sort of going to come pretty soon to fix the issues here, that I think is specifically related to things like, if you have a Git dependency whose branch includes a plus in the name, then it's going to be encoded incorrectly because they don't escape it the way that the URL library wants them to. There's another couple of really nice changes to cargo. One of them is the cargo update will now tell you if you did an update, but there is a newer version available. So imagine something like, you took a dependency on, I don't know, nom 5, and you previously had nom 5.4.3, and it's been updated to 5.6.8. Then cargo will tell you, okay, I'm updating nom from this version to that version, and will also tell you the latest version of nom is version 7. So in other words, it warns you that you're not on the latest version that you could be, but I did update you as far as I could. And so I think this is a really nice way to indicate to people that they're behind, even though cargo update succeeded. The other thing that happened is 178, and this has sort of been a long time coming as well, is that cargo a long time ago decided that They want to use toml for configuration files, and they want those toml files to have the .toml extension. But they still accepted both. So you could have a .cargo/config, and you could have a .cargo/config.toml, and if you had both, the toml file would sort of win out. But with 178, they've now officially deprecated the support for non-extension files. And so at this point, you now actually get a warning if you have a config file that doesn't have the toml extension. Again, not really that big of a difference because this has already been the case for a while, but at least now it's made visible, sort of similar to the cargo update thing, that it's visible that you're not getting quite what you wanted. And I think that's all I really wanted to talk about for 178. There's a Clippy lint actually that I noticed. I don't normally look at all the Clippy lints because there are so many, but there was one last one that I saw that struck me as interesting, which is if you have code that does something like foo equals bar.clone, where foo is a value you already have, like you're not creating a new foo, then Clippy will now lint you telling you instead of doing foo equals bar.clone, use clone from. So if you don't know what clone from is, the clone trait actually has two methods, not one. The clone trait has the clone method, which we all know and love and use all the time, but it also has the clone from method, which specifically is, it takes a mutable reference to self and a shared reference to another instance of self, and then it clones from that other one into self. The idea here being that for a bunch of types, you can actually avoid some allocations this way by reusing the values that already are stored in self, things like vectors. And so this might save you some allocations, but if you do foo equals bar.clone, you can't make use of those because the foo is never given into the cloning process. And so in general, for those, you should always prefer to clone from bar. So foo.clone from bar rather than just reassigning a new clone. And so I thought that was an interesting Clippy lint that I'm happy to see land. It is probably going to trigger a lot for people, which is why I thought it was probably worth highlighting.
On the topic of Clippy lints, there's another one called incompatible MSRV, where it's actually beginning to... MSRV is the minimum supported Rust version. And the idea here is that a crate can, in their current toml file, say, hey, I only want to... This crate only supports Rusts of this and above. The minimum version. The idea here being that if you say you standard library comes out with new APIs all the time, if you want to use that new API in your library, but one of your downstream users, isn't on a version of Rust new enough to actually have the API in their version of Rust, previously they get kind of a pretty bad error. And this way, the idea of MSRV is that you can say, hey, downstream users, it looks like, you're trying to compile with version of Rust some old thing, but it requires at least this version, so upgrade your compiler if you want to compile my library. And so this new Clippy lint now actually enforces it in your library, right? I think that's what this does, right? So this lint checks that no function newer than the defined MSRV is used in the crate. And so when your crate defines an MSRV, previously it was kind of just as a crate author, I kind of just happen to know what MSRV is correct, but now is actually a way to check it for you. And so I think is a good next step for actually enforcing MSRV.
Yeah, and I think it reads it out of the Rust version field of your package in your cargo toml, right?
Mm-hmm. Yeah.
Is there anything from the Reddit thread that we should talk about?
ePage, more cargo stuff. Wanted to just kind of highlight some stuff, which is that if you do cargo new, it no longer adds a boilerplate comment in your little hello world file there.
Oh, nice.
So if you get an error for this package is declared to be incompatible with your Rust version, so more MSRV stuff, and now reports all of them at once rather than having to go through one at a time. And you mentioned the cargo update thing. So that's the only thing.
Yeah,
so
the cargo update thing makes me very happy. I think it happens so much that people are behind on their dependencies and they just never realize. And at that point, you never get updates either, right? Because you're on an old major version. And so there's just no indication that you should probably upgrade.
Yeah, it's a trap where you get stuck at the newest version of the old major version you have.
Exactly. So. And I think with that, we're all done, Ben. We got all the way through.
Dun, 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 dun. Dun, 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 dun.
Nice.
We made it. We crossed the line.
Chariots
of fire.
We did end up at almost 6 hours, so it was longer than I thought it would be. But we've somehow survived, which I think is pretty exciting stuff. Although I can feel my brain is not fully present anymore.
So the our PR is still in the rollup. That's fine. That's reasonable. So
Let's
it'll work its way
see.
through.
It is. Yeah, it's not even pending yet. That's sad. We're so close.
That's all right. It's all right. We made great progress here today. Although it occurs to me that we forgot to record outros for all the previous versions. Should we just record one once and then just like reuse it?
Yeah, it's true.
So it doesn't just like slam to silence.
I mean, I think the way we would do this, right, is we would just say, and now for something completely different, and then just cut it there, and then the next episode just picks up from like a
The
random
editor
point.
just takes that soundbite from you just now and uses that. Yeah, there you go. Perfect.
Yep, great. We've had it. We have every transition we could ever need. I think we can call it there then. I'll monitor this PR in the background. I'll switch so that people can't see my screen. Now they can just see our faces. Well, in that case, I'm gonna say thanks to Ben because it is now 10:30 p.m. here and I need to start to go to bed. And thanks to chat because it's way more fun to do this with chat than without chat. Otherwise, we would have died, I think, Ben. We need someone to keep us going. But now that we are back up to speed, now maybe we can hit a normal release cadence. But even if we don't, it's fine. It doesn't matter. We do this
it
for
was
fun.
so much fun. We should just wait another 6 months before doing it again.
And maybe that's going to have been intentional all along. All right. Well, bye everyone. Thanks for coming out. So long, farewell, auf Wiedersehen, goodbye, and thanks for all the fish. Oh, so good. So good.